NASA just found something monstrous roaming at the bottom of the ocean world. They had just one mission: hunt down aliens. Instead, they found something worse, hiding right here on Earth. During one deep-sea expedition, instruments picked up a reading that should not have been possible. Oxygen, pouring out of complete darkness, thousands of feet down where sunlight has never once reached. Nothing down there should have been able to make that oxygen. And what was making it would change everything we thought we knew about the ocean. Why NASA went to the bottom of the ocean? The ocean has been winning this fight for a very long time. Every time people built a machine they believed could finally reach the deepest parts of the planet, the ocean found a way to break it. The deeper you go, the more violent the pressure becomes. At the bottom of the Mariana Trench, the pressure is more than 1,000 times greater than the sea level. For decades, that pressure kept humanity out. Scientists knew the deepest parts of the ocean had to be different. Strange animals had floated to the surface: fish with transparent heads, creatures with no eyes, animals built to survive pressure that would instantly crush anything from the world above. Some people even wondered whether something far stranger could be hiding down there. Nobody actually knew, because almost nobody had ever been there. Then, after years of engineering, scientists finally believed they had built the machine that could change that. Its name is Nereus. This wasn't just another underwater robot. It is one of the most advanced deep-sea research vehicles ever created. It could travel deeper than almost every other machine on Earth. It collected samples. It photographed places no human being had ever seen. For the first time, scientists believed they finally had a vehicle that could work in the deepest trenches. Then came May 10, 2014. Researchers lowered Nereus into the Kermadec Trench, one of the deepest places on Earth. The vehicle began its descent. The instruments kept reporting back. Hour after hour, the mission unfolded exactly as planned. Nearly 7 hours passed. Only 2 hours remained before the dive was supposed to end. Then the signal disappeared. At first, nobody panicked. The team tried again. Nothing. Minutes turned into more minutes. The silence inside the control room became harder and harder to ignore. Then the ocean gave them its answer. Pieces of Nereus began floating to the surface. The vehicle hadn't broken down. It hadn't run out of power. The ocean had crushed it. That single moment changed everything. Because scientists suddenly realized they weren't losing to bad engineering. They were losing to the way they had been thinking. So the next question wasn't, how do we build an even bigger robot? It was, what if we stopped depending on one machine altogether? That question led to Orpheus. Instead of another giant research vehicle costing millions of dollars, scientists built something much smaller. Small enough to fit in the back of a pickup truck. Cheap enough that losing one would no longer end an entire research program. But size wasn't the real breakthrough. The real breakthrough was the way Orpheus finds its way across a place where there is no sunlight, no GPS, and no map. As it moves across the seafloor, it constantly photographs the landscape beneath it, every cliff, every rock. A few seconds later, it compares the next image with the one it just saw. Little by little, it builds its own map while it's still exploring. That means it can return to the exact same place again without anyone steering every movement from the surface. It doesn't just look at the ocean floor, it learns it. And that's exactly what caught NASA's attention. NASA's Jet Propulsion Laboratory partnered with Woods Hole Oceanographic Institution because the challenge beneath Earth's oceans looked strangely familiar. Because of isolation, no GPS, no radio signals, no human pilot, complete darkness. A robot has to make decisions on its own. The same kind of problem NASA faces on other worlds, especially one, Europa, a frozen moon orbiting Jupiter. Scientists believe that beneath its thick shell of ice lies an ocean containing more liquid water than all of Earth's oceans combined. No sunlight has ever reached that ocean. If anything lives there, it has spent its entire existence in complete darkness. That may sound like science fiction. Then Saturn changed everything. NASA's Cassini spacecraft flew through enormous plumes of water erupting from another icy moon called Enceladus. Inside those plumes, scientists detected water, organic molecules, and molecular hydrogen. Not proof of life. Suddenly, hidden oceans became places scientists genuinely wanted to explore. which is why NASA came to the bottom of Earth's ocean first, because it's the closest place we have to practicing for another one. And the deeper scientists looked, the more often the ocean answered with something nobody thought could exist: life. And it happened because 3 scientists looked through the tiny windows of a submarine called Alvin, life that should not exist. In 1977, a small research submarine called Alvin sank through the cold, black water of the Pacific Ocean near the Galapagos Islands, and the 3 scientists inside pressed their faces against the tiny porthole windows and watched the darkness outside as the submarine descended. They were expecting nothing: cold, black, empty. Scientists believed that without sunlight reaching the sea floor, nothing complex could survive down there. A few scavengers, maybe. Bacteria, the occasional creature drifting through the dark, eating whatever scraps fell from the world above. The assumption was so deeply embedded in biology that nobody seriously questioned it. Every living thing on Earth depended on the sun. Plants converted sunlight into energy. Animals ate the plants. Even deep ocean creatures ultimately traced their food back to the surface and the light above it. The sun was not just important to life. It was where life began. Every time. Without exception. And then the lights of the Alvin swept across the sea floor and the scientists inside stopped breathing. What was growing around the cracks in the seafloor, the hydrothermal vents where superheated water erupted from deep inside the Earth at temperatures exceeding 750 degrees Fahrenheit, should not have existed. Tube worms growing up to 8 feet tall with brilliant red plumes reaching toward the darkness above them. Giant clams the size of dinner plates packed so tightly they covered the seafloor in white. Crabs moving through what biology said was a dead zone. Bacteria coating every rock and every surface in thick living mats. Ecosystems so dense and so rich and so impossibly alive that the scientists inside that submarine could not process what they were seeing. One of them reportedly radioed the surface and asked, "Isn't the deep sea supposed to be like a desert?" It was not a desert. It was one of the most densely populated environments on the planet, and none of it had anything to do with the sun. The key was chemosynthesis. Bacteria living around the vents were pulling hydrogen sulfide directly from the superheated water, the same toxic gas that smells like rotten eggs and kills most organisms at even low concentrations, and converting it into energy through chemical reactions that needed no sunlight at all. These bacteria became the foundation of an entire food chain built not on light, but on the chemistry pouring out of the Earth itself. The tube worms that grew 8 feet tall in the darkness had no mouths, no stomachs, no digestive systems of any kind. The bacteria fed the worm. The worm provided the bacteria with the chemicals they needed from the vent water. 2 organisms locked together in a partnership so complete and so dependent that neither could survive without the other, growing to 8 feet tall in boiling toxic water at the bottom of the ocean in complete darkness with no connection to sunlight anywhere in their biology. Not surviving, thriving. The moment that discovery reached the surface, it cracked the search for alien life wide open. If organisms could build entire ecosystems in total darkness powered entirely by chemistry from the Earth itself, then life could exist beneath the frozen ice of Europa, where the ocean floor might have its own hydrothermal vents pumping chemical energy into the water above. The assumption that life required sunlight was gone. And with it went the assumption that the only place life could exist was somewhere that looked like the surface of Earth. But the deeper scientists pushed, the more disturbing the ocean became. The shrimp living beside the vents had been transformed by the darkness into something that should not be possible. As adults, they lost their eyes completely. The organs dissolved and disappeared as the shrimp matured, leaving smooth, featureless skin where the eyes had been. In their place, the shrimp developed a specialized organ across their backs, a strip of tissue sensitive to the infrared radiation emitted by the hot vent fluids, allowing them to feel the heat of the vents the way a human eye sees light. They crowded around the chimneys in masses of thousands, pressing as close to the boiling outflow as they could get without cooking alive, positioning their bodies at the precise line between lethal heat and lethal cold, navigating that line using an organ that should not exist on an animal that lost the ability to see. And when the bacteria thinned and the food ran out, they ate each other. Not occasionally, not as a last resort, as a documented behavioral response to scarcity. Cannibal colonies packed around the edge of boiling water in absolute darkness. Their existence was already something biology could barely account for. Their behavior when they were hungry was something darker still. Then scientists found the brine pools, and the darkness got worse. At the bottom of the Gulf of Mexico, sitting on the seafloor like something from the worst kind of dream, were lakes, actual lakes, sitting underwater. The water inside them was 5 times saltier than the surrounding ocean, so impossibly dense that it formed a visible shoreline on the sea floor, a distinct shimmering boundary between the normal ocean above and the toxic brine below. Fish that wandered across that boundary did not turn back. They could not. The brine seized their bodies and poisoned them within seconds, and they died at the shoreline, twitching and then still, their bodies piling up at the edge of the water in drifts. Researchers watching from submersibles filmed those bodies accumulating at the line where the brine began, and they named what they were looking at the underwater lakes of death. And around the shores of those lakes of death, enormous colonies of mussels and tube worms were living in densities that rivaled the richest ecosystems on the surface of the planet. Fed by bacteria consuming the methane and hydrogen sulfide seeping from the sediment beneath the brine. No sunlight, no plants, no connection to anything above, just chemistry sustaining abundant life at the very edge of something that killed almost everything it touched. Methane seeps elsewhere on the seafloor pushed further still into territory that biology had no framework for. Eyeless worms burrowing through solid methane ice, bacteria feeding directly on toxic gas, mussels hosting microbes inside their own tissue that fed them the way a mother feeds a child. Each environment a completely separate world operating on completely separate rules with no awareness of the surface and no need for it. Each one a proof carved into the rock of the seafloor that life did not need what science had always said it needed. The sunlight assumption was gone, but something even more fundamental was about to break. Because scientists had been looking at life without sunlight, life at the extreme edge of what conditions could sustain. Life that was still connected, however distantly, to water and ocean, and the chemistry flowing through the cracks in the earth. What they had not yet found was life with no connection to anything at all. They found it in a gold mine, 3 kilometers underground, in the dark, completely alone, and it had been there for longer than our species had existed on Earth. Life inside the rock. Nobody sent anyone to that gold mine looking for life. Tullis Onstadt was a geologist from Princeton University. In the late 1990s and early 2000s, he was drilling into ancient rock nearly 3 kilometers below the surface of South Africa, deeper underground than most humans have ever gone, studying water that had been trapped in fractures in the stone for an almost incomprehensible length of time. The work was about geology, about understanding what happens to rock and water when they are sealed together in darkness under enormous pressure for millions of years. And then someone looked at what was living in that water. The organism they found had no name because nothing like it had ever been found before. Scientists eventually named it Candidatus desulphurutus audaxviator, the bold traveler, a name pulled from Jules Verne's Journey to the Center of the Earth, because whoever named it understood that what they were looking at was something out of a story nobody had believed was real. It was living nearly 3 kilometers underground, in water sealed away from the surface of the Earth for somewhere between 1 million and 100 million years. No sunlight, no oxygen from above, no connection to any ocean or any vent or any ecosystem that had ever been described in any biology textbook ever written. It was consuming hydrogen and sulfate produced by the slow radioactive decay of the minerals in the surrounding rock and converting them into the energy it needed to survive. One species, alone, running an entire ecosystem by itself in complete darkness nearly 3 kilometers below the surface of the Earth. Think about what that actually means. On the surface of this planet, even the most isolated ecosystems involve hundreds of species interacting in webs of dependence so complex that scientists spend entire careers trying to map them. The bold traveler needed none of it. No partners, no competitors, no predators, no prey. It had been sealed inside the rock of the Earth since before modern humans existed, and it had sustained itself completely alone through every ice age, every mass extinction, every catastrophe that reshaped the surface world above it, without any awareness that any of those things had happened. The drill bit that reached it was probably the first thing to disturb it in millions of years. And when the water around it was brought to the surface and examined, the bold traveler was not in distress. It was not dying. It was simply living in the dark, in the rock, exactly as it had been living for longer than our entire species has existed. That discovery broke something fundamental in the search for alien life. Before the bold traveler, scientists searched for life in what they called the habitable zone, the narrow band of orbital distance around a star where conditions on a planet's surface might allow liquid water to exist in sunlight. The assumption was that life needed a surface, needed warmth from above, needed to exist in the zone where the star's energy could reach it. Mars was considered almost certainly dead because its surface is a frozen, barren wasteland bombarded by radiation. Europa was considered a long shot because its ocean was buried under miles of ice with no sunlight reaching it. The entire framework of the search for life was built on the idea that the surface was where life happened. The bold traveler tore that framework apart. If one species could survive for millions of years in total darkness nearly 3 kilometers underground powered only by radioactive decay in the surrounding rock, then the interior of almost every rocky planet that has ever formed anywhere in the universe is a potential habitat for life. The inside of a planet does not need to be in the habitable zone. It does not need sunlight. It does not need a surface that looks like Earth. It just needs rock. And rock exists everywhere. Mars has extensive underground geological formations where isolated pockets of liquid water may still exist deep beneath its frozen surface. The same radioactive minerals that fed the bold traveler exist in Martian rock. The same chemical reactions that powered a single species through millions of years of complete isolation could theoretically be powering something similar right now beneath the surface of a planet that every scientist in 1976 would have declared completely dead. After the bold traveler, NASA began redesigning its approach to Mars. The search for life stopped looking at the surface and started looking beneath it. Europa's ocean sits in direct contact with its rocky seafloor. If hydrothermal vents exist on that ocean floor, and the evidence suggests they might, then the chemistry that sustained those tube-worm ecosystems in complete darkness on Earth could be sustaining something similar in complete darkness beneath Europa's ice right now. Enceladus has confirmed warm regions near its south pole where liquid water interacts directly with hot rock. The conditions in both places bear a striking resemblance to the conditions in a South African gold mine nearly 3 kilometers underground. Complete isolation. No sunlight. Chemistry from rock as the only available energy. The model for what alien life might look like was no longer science fiction. It was sitting in a sample bottle from a mine. And then scientists looked at the seafloor itself and found something that made even the bold traveler seem almost expected. They found oxygen appearing in complete darkness at the bottom of the ocean, with no biological source, with no sunlight, with nothing alive producing it, just rocks, making breathable air in the dark. Oxygen in the dark. For nearly a decade, Sweetman, a marine scientist at the Scottish Association for Marine Science, had been running the same experiment in the Clarion-Clipperton Zone, a vast stretch of the Pacific Ocean floor sitting 13,000 feet below the surface in complete darkness. The experiment was straightforward. Lower sealed chambers onto the seafloor. Let them sit. Measure the oxygen level inside over time. Watch it fall as the organisms inside the chamber consumed it. Simple. Predictable. The kind of experiment that should produce the same result every time because the result is governed by one of the most basic rules in biology. Oxygen goes down. Organisms consume it. There is no other possibility, except the oxygen kept going up. The first time it happened, Sweetman assumed the sensors were broken. He bought new sensors. The oxygen still went up. He changed his measurement technique entirely, abandoning electronic sensors and switching to a classical chemical method that had been used reliably in ocean science for over a century. The oxygen still went up. He tried different locations across the zone, different depths, different sediment types, different equipment configurations. The oxygen kept going up every single time. in sealed chambers at the bottom of the ocean in complete darkness with no sunlight and no photosynthesis and no known biological mechanism that could explain it. The oxygen levels inside those chambers rose instead of falling, and Sweetman could not explain it, and it made him furious. He told himself the results were instrument error. He moved on. He came back. The results were still there. He ignored them for months at a time. He came back again. Still there. For nearly a decade, he dismissed what his own data was showing him because the alternative, taking it seriously, meant accepting something that every principle of marine science said was impossible. And then he poisoned the chambers. Mercury chloride is a powerful poison that kills microorganisms completely at concentrations far lower than what Sweetman used. He flooded the sealed chambers on the seafloor with it to eliminate every living thing inside. If some unknown species of bacteria was producing the oxygen through a biological process nobody had yet identified, killing every microorganism in the chamber would stop it. He was certain of it. He lowered the poison chambers down 13,000 feet. He waited. He brought them back up. He measured the oxygen. It had gone up. Whatever was producing oxygen in those chambers at the bottom of the ocean was not alive. He had killed everything alive inside them, and the oxygen still appeared. He sat with that result for a long time, and then he stopped throwing his sensors in the bin and started looking at the rocks. The polymetallic nodules carpeting the seafloor of the Clarion-Clipperton Zone are not impressive to look at. Potato-sized lumps of dark mineral sitting on the sediment, growing at a rate so slow it takes millions of years to add a single centimeter of material. They accumulate manganese, cobalt, nickel, and copper from the seawater above them, layer by infinitesimal layer, over timescales that make human civilization look like a rounding error. Scientists had studied them for decades. Mining companies had been eyeing them for years as a source of the metals used in electric vehicle batteries. Nobody had thought to ask what they were doing electrically. Sweetman's team measured the voltage on the surface of the nodules and found something that made the room go quiet. Individual nodules were producing up to 0.95 volts of electrical charge on their surfaces, just under the voltage of a standard AA battery. When multiple nodules clustered together, which they did across vast stretches of the Clarion-Clipperton Zone, the combined charge could potentially become sufficient to split seawater molecules apart through electrolysis, the same process used in laboratories to separate water into its component parts, hydrogen and oxygen. Rocks, sitting on the seafloor in total darkness, growing for millions of years, building up electrical charge layer by layer as different metals accumulated at different rates, and then potentially using that charge to crack seawater apart and release breathable oxygen into the water above them with no sunlight and no biology and no living organism involved in any part of the process. The paper was published in Nature Geoscience in 2024. The finding hit the scientific community like something thrown through a window, not because everyone accepted it, because of what it meant if it was true. The Clarion-Clipperton Zone stretches approximately 4,500 miles across the eastern Pacific Ocean. Its seafloor is carpeted with these nodules across an area so vast it is difficult to comprehend, and 16 companies currently hold deep-sea mining licenses there. They are planning to send machines to the bottom of that ocean to hoover those nodules off the seafloor in enormous quantities to extract the metals inside them for the electric vehicle batteries that are supposed to help save the surface world from climate change. The dark oxygen discovery means that the rocks those companies are planning to tear from the seafloor may be generating the only source of oxygen available to every organism living at 13,000 feet below the surface. Removing them could suffocate ecosystems that scientists have not even finished discovering yet. The machines built to save the planet above may be about to destroy a world below that nobody fully understands. The finding is contested. A paper published in Frontiers in Marine Science argued that the proposed mechanism, the idea that the nodules act as natural geobatteries, appears to violate thermodynamics. The energy required to split seawater into hydrogen and oxygen exceeds what the researchers have demonstrated the nodules can generate. No other research team has independently replicated what Sweetman observed. The scientific debate is real, and it is ongoing, and it has not been resolved. But here is what the finding does to the search for alien life, regardless of whether it is ultimately confirmed. For decades, the presence of oxygen in a planet's atmosphere has been considered one of the most powerful signals scientists could detect when searching for life beyond Earth. Oxygen is produced by photosynthesis. Photosynthesis requires life. Where there is atmospheric oxygen, there may be living organisms producing it. That logic has shaped the design of telescopes, the targets of space probes, and the fundamental strategy of the search for biosignatures on worlds orbiting distant stars. It is one of the cornerstones of astrobiology. If rocks can produce oxygen in complete darkness at the bottom of an ocean with no biological input whatsoever, then detecting oxygen in the atmosphere of a planet light years away tells scientists nothing definitive about whether life is there. The signal that was supposed to be one of the clearest indicators of biology in the universe may just be an indicator of certain kinds of rocks under certain kinds of conditions. The cornerstone cracks. No sunlight needed to sustain life, no surface connection needed, no other species needed, and now potentially no life needed to produce the oxygen that was supposed to prove life existed. Every requirement that science had believed was non-negotiable had been found at the bottom of Earth's ocean and quietly dismantled, and NASA had been watching every single discovery as it happened, each one changing something about how they searched for life beyond this planet. Each one rewriting a rule that everyone had assumed was permanent. Now they had to decide what to do with all of it. Oxygen in the dark. Andrew Sweetman told his students to throw the sensors in the bin. It was not the first time. It would not be the last. For nearly a decade, Sweetman, a marine scientist at the Scottish Association for Marine Science, had been running the same experiment in the Clarion-Clipperton Zone, a vast stretch of Pacific Ocean floor sitting 13,000 feet below the surface in complete darkness. Lower sealed chambers onto the seafloor, measure the oxygen level inside over time, watch it fall as organisms consume it. Simple, predictable, governed by one of the most basic rules in biology. Oxygen goes down. There is no other possibility, except the oxygen kept going up. The first time it happened, Sweetman assumed broken sensors. He bought new ones. Same result. He changed his measurement technique entirely, abandoning electronic sensors for a classical chemical method that had been used reliably for over a century. Same result. He tried different locations, different depths, different equipment. The oxygen kept rising inside sealed chambers at the bottom of the ocean in complete darkness, where no sunlight could reach and no photosynthesis could occur, and nothing should have been producing anything. He dismissed the results for nearly a decade, told himself it was instrument error, moved on, came back. The results were still there, waiting for him every time like something that knew he would eventually have to look at it properly. And then he poisoned the chambers. Mercury chloride kills microorganisms completely at concentrations far lower than what Sweetman used. He flooded the sealed chambers with it on the seafloor to eliminate every living thing inside. If some unknown bacteria was producing the oxygen, killing everything biological would stop it. He lowered the poisoned chambers 13,000 feet down. He waited. He brought them back up and measured the oxygen. It had gone up. Whatever was producing oxygen in those chambers was not alive. He had killed everything alive inside them, and the oxygen still appeared. He stopped throwing his sensors in the bin and started looking at the rocks. The polymetallic nodules carpeting the seafloor of the Clarion-Clipperton Zone are not impressive to look at. Potato-sized lumps of dark mineral sitting on the sediment, growing so slowly it takes millions of years to add a single centimeter of material, accumulating manganese, cobalt, nickel, and copper from the seawater above them, layer by layer across timescales that make human civilization look like a rounding error. Scientists had studied them for decades as mining targets. Nobody had thought to ask what they were doing electrically. Sweetman's team measured the voltage on the nodule surfaces and found something that silenced the room. Individual nodules produced up to 0.95 volts of electrical charge, just under the voltage of a standard AA battery. When multiple nodules clustered together, which they do across vast stretches of the sea floor, the combined charge could potentially become sufficient to split seawater molecules apart through electrolysis, cracking water into its components and releasing breathable oxygen into the darkness above. Rocks, sitting on the sea floor for millions of years, building electrical charge layer by layer, and potentially making oxygen in complete darkness with no sunlight and no biology involved in any part of the process. The paper was published in Nature Geoscience in 2024. The finding detonated through the scientific community, not because everyone accepted it, because of what it meant if it was true. The Clarion-Clipperton Zone stretches approximately 4,500 miles across the eastern Pacific. 16 companies currently hold deep-sea mining licenses there. They are planning to send machines to the bottom of that ocean to strip those nodules from the seafloor in enormous quantities to extract the metals used in electric vehicle batteries. The dark oxygen discovery means the rocks those companies intend to remove may be generating the only oxygen source available to every organism living at 13,000 feet. Removing them could suffocate ecosystems that scientists have not even finished identifying. The machines built to help save the surface world may be about to destroy a world below that nobody fully understands. The finding is contested. A paper in Frontiers in Marine Science argued the proposed mechanism appears to violate thermodynamics. The energy required to split seawater exceeds what the nodules have been shown to generate. No other team has independently replicated the observation. The debate is real and unresolved, but here is what it does to the search for alien life, regardless of whether it is confirmed. For decades, the presence of oxygen in a planet's atmosphere has been considered one of the most powerful signals in the search for life beyond Earth. Oxygen is produced by photosynthesis. Photosynthesis requires biology. Where there is atmospheric oxygen, there may be living organisms. That logic shaped the design of telescopes, the targets of space probes, and the entire framework of the search for biosignatures on distant worlds. If rocks can produce oxygen in complete darkness at the bottom of an ocean with no biological input whatsoever, then finding oxygen in the atmosphere of a planet light years away tells scientists nothing definitive about whether life is there. The signal that was supposed to be one of the clearest indicators of biology in the universe may just be an indicator of certain kinds of rocks under certain kinds of pressure. The cornerstone of the search for alien life develops a crack that nobody knows how to fill. No sunlight needed to sustain life. No surface connection needed. No other species needed. And now potentially no life needed to produce the oxygen that was supposed to prove life existed. Every requirement science believed was essential had been dismantled one discovery at a time at the bottom of Earth's ocean. And NASA had been watching every single one of them happen. Asterisk, asterisk. What NASA does with all of this asterisk, asterisk. Off the coast of Key Largo, Florida, 62 feet below the surface of the Atlantic Ocean, NASA astronauts live inside a steel cylinder the size of a school bus. They sleep there, they eat there, they work there. They look out through small portholes at fish moving through coral reefs in the blue water outside, and they train for missions to the Moon and to Mars, and eventually to worlds beyond both. The habitat is called Aquarius. It is the world's only permanent undersea research station, operated by Florida International University, and NASA has been using it since 2001 for a series of missions called NEMO, NASA Extreme Environment Mission Operations. The isolation, the confinement, the hostile environment directly outside the walls, the limited communication with the surface above, the absolute dependence on systems that cannot fail because there is nowhere to go if they do. All of it mirrors what astronauts will face on deep space missions to places so far from Earth that no rescue is possible, and no resupply is coming, and the only thing standing between the crew and death is the integrity of whatever they brought with them. The ocean became a rehearsal for the most dangerous journeys humanity has ever planned. But the NEMO missions, as important as they are only the most visible surface of what NASA has taken from the ocean, because every single discovery made in the deep, the hydrothermal vents, the cannibal shrimp, the brine pools, the bold traveler sealed in its gold mine for millions of years, the oxygen rising in poisoned chambers in the dark, every one of those discoveries did something specific and direct to how NASA searches for life beyond this planet. The vents changed Europa. When scientists found ecosystems thriving without sunlight on chemical energy at the bottom of Earth's ocean, NASA looked at Europa differently. If life could power itself on the chemistry pouring from cracks in a seafloor in total darkness, then Europa's ocean, which sits in direct contact with its rocky floor, needed to be examined for exactly that kind of chemistry. The instruments on Europa Clipper were designed with Earth's hydrothermal vents in mind. The mission is looking for the chemical signatures of geological activity on the ocean floor beneath the ice. It is looking for the kind of energy that feeds tube worms and blind cannibal shrimp in complete darkness 750 feet below the surface of the Pacific. Because if that energy exists under Europa's ice, then what lives there might not be so different from what lives around Earth's vents. The gold mine changed Mars. Before Tullis Onstad found the bold traveler nearly 3 kilometers underground in South Africa, Mars was a surface problem. Scientists looked at the barren, frozen, radiation-blasted surface and concluded that the chances of anything surviving there were essentially zero. After the bold traveler, Mars became a subsurface question. If life can power itself on radioactive decay and total darkness 3 kilometers underground with no connection to any surface world for millions of years, then the fact that Mars's surface is hostile to life means almost nothing about what might exist beneath it. NASA began redesigning its Mars exploration strategy. The instruments got pointed downward. The questions shifted underground. The search for life on the planet most people had already given up on moved into the rock. And the dark oxygen changed everything else. If the nodule discovery is confirmed, if rocks really can produce oxygen through geology alone in complete darkness, then the signal that scientists have been using to search for life on distant worlds for decades is no longer reliable. The presence of oxygen in a planet's atmosphere was supposed to be one of the clearest signs that biology was present. That assumption is now in question. And when a cornerstone of your search strategy turns out to be built on uncertain ground, everything built on top of it has to be re-examined. The telescopes searching for biosignatures on exoplanets, the criteria used to select which worlds to study, the entire framework of how humanity decides where to look for life in a universe containing hundreds of billions of galaxies, each containing hundreds of billions of stars. All of it touched by something found at the bottom of Earth's ocean. NASA's Europa Clipper is traveling toward Jupiter right now. It will arrive at Europa in 2030. It will conduct approximately 50 close flybys of a moon whose hidden ocean may already be full of life operating on the same principles as the impossible ecosystems at the bottom of our own ocean. Every impossible thing found in Earth's deep water shaped the mission that is flying toward it. The vents, the isolated microbes, the oxygen appearing where oxygen should not exist. Each discovery a lesson. Each lesson built into the spacecraft moving silently through the dark between planets. And here is what all of it adds up to when you place the pieces together. A planet with a completely separate world inside it and beneath it. Ecosystems running on chemistry with no sunlight. Life in complete isolation for millions of years powered by the slow decay of radioactive rock. Oxygen potentially produced by geology alone in complete darkness at the bottom of a sea. All of it existing not on a distant moon, but at the bottom of the ocean that humanity has lived beside for its entire existence without knowing any of it was there. Less than 25% of Earth's ocean floor has been mapped in any meaningful detail. Everything discovered so far has been found in a fraction of the total unexplored territory. The hydrothermal vents, the brine pools, the bold traveler in its gold mine, the dark oxygen in its poisoned chamber. All of it found in the small fraction of the deep that humans have actually managed to reach. Whatever lives in the remaining 75% of the seafloor is still down there in the dark, still waiting, completely unaware that anything above it is looking. Somewhere beneath the ice of Europa, there may already be ecosystems feeding on chemical energy in total darkness near vents on an alien ocean floor. Somewhere inside the rock of Mars, microbes may be surviving in isolated pockets of ancient water, the way the bold traveler survived in its gold mine for longer than our species has walked the Earth. Somewhere in the oceans of worlds orbiting stars so distant that their light takes thousands of years to reach us. Life may exist in forms and conditions that every biology textbook written before 1977 would have declared flatly impossible. The bottom of Earth's ocean did not answer the question of whether we are alone in the universe. It did something more unsettling than that. It changed what the question means. It stopped asking whether other worlds have the conditions for life as we imagined it, and started asking whether they have the conditions for life as we now know it actually works. In the dark, under crushing pressure, without sunlight, on chemistry from the rock itself. And the answer to that question, based on everything pulled up from the bottom of Earth's ocean and everything flying toward Europa right now, is beginning to look like yes. Everywhere.